Have you ever gazed up at the night sky and wondered where it all came from? What sparked the Big Bang? That colossal event that birthed our entire universe. It's a question that has baffled scientists and philosophers for generations. Imagine, for a moment, a single, infinitesimal point, a point containing all the matter and energy of the cosmos, suddenly expanding in an explosive burst of creation. This event, happening nearly 14 billion years ago, marks the very beginning of time and space as we know it. The conventional story, the one you might find in a textbook, is that the universe began from this hot, dense state. But what if that wasn't the asterisk? True. Asterisk beginning. Modern cosmology paints an even more dramatic picture. There was likely a phase asterisk before asterisk the Big Bang, a period called cosmic inflation. Think of it this way. The universe was accelerating exponentially fast, doubling and redoubling in size at a mind-boggling rate. If you started with a universe smaller than a single atom, in less than a fraction of a second, it would have ballooned to be vastly larger than the entire observable universe we see today. That's a space containing over 350 billion galaxies. When this incredibly rapid expansion stopped, all the energy that was driving it got dumped into space. It heated everything up and created the very particles of matter that make up you, me, and everything out there in the sky. And that asterisk is what we observe as the afterglow of the Big Bang. It might sound like science fiction, but this is the leading theory right now. Of course, this just pushes the question back a step further. What started inflation in the first place, and what made it stop? The honest answer? We're not quite sure. This journey back to the origin of the universe takes us to a realm where our conventional laws of physics break down. It's important to clarify something. The Big Bang wasn't an explosion asterisk in asterisk space. It was the rapid expansion asterisk of asterisk space itself. At the very heart of this expansion is the concept of time. But how was time even created? At time zero, the moment of the Big Bang, our universe was a singularity, a point of infinite density and temperature. At this extreme scale, our current understanding of physics simply falls short. This singularity marks not only the birth of matter and energy, but also the dawn of time itself. As the universe expanded and cooled, fundamental particles began to form, eventually leading to atoms. The faint glow we can still detect today, the cosmic microwave background radiation, is a relic from that ancient Iran. Echo of the moment the universe became transparent. But this still leaves us with the ultimate question. What was there at time zero? Was there anything asterisk before asterisk? The Big Bang? Or was it the absolute beginning? It's a tricky question, and the answer might be that the question itself doesn't make sense. We understand the words the moment before the Big Bang, but it could be that when it comes to the actual event, the sentence is meaningless. It's possible that the Big Bang was the very moment when time itself began. You can talk about 1 billion years ago or 10 billion years ago, but if you go all the way back 13.8 billion years, you might hit the starting line, and you can't go further back in time than the origin of time itself. So, as we delve deeper, we enter a realm of fascinating and complex theories. One leading idea is quantum fluctuations. In the strange world of quantum mechanics, even a perfect vacuum isn't truly empty. It buzzes with energy and random fluctuations. It's possible that one of these tiny, spontaneous changes was enough to trigger the immense expansion of the Big Bang. Another mind-bending idea is the multiverse theory. It suggests that our universe is just one bubble in a vast cosmic foam of endless universes. In this scenario, the Big Bang might have been a transition from one state in the multiverse to another, like a new bubble forming in boiling water. Then there's string theory, which proposes that the Big Bang could have been caused by the collision of higher dimensional objects called brains. Imagine two cosmic membranes crashing into each other, releasing an unimaginable amount of energy that gave birth to our universe. Each of these theories tries to answer the why of the Big Bang. Why did it happen? But perhaps why is the wrong question to ask. Asking why implies a purpose or a reason. In cosmology, the more productive question might be how. How did the conditions align for such an event? How did physical laws and random chance converge to create our universe? By shifting our focus from seeking a purpose to understanding the process, we inch closer to unraveling this grand mystery. For a physicist, the quest is to trace everything back to the very beginning. We've made incredible progress. Thanks to precise measurements, we know the universe is about 13.8 billion years old. We know that everything we can see today, every star, every galaxy was once compressed into a space smaller than an atom. It's a staggering thought. From that initial, hot, dense ball of energy, the universe expanded and cooled. As it cooled, complexity began to emerge. First particles, then atoms, and eventually, stars, planets, DNA, and people. How do we figure all this out? One way is to look up, to build powerful telescopes that peer back in time. The other way is to look down, to build massive machines like particle accelerators that recreate the extreme conditions that were present moments after the Big Bang. These experiments allow us to test our theories about the fundamental nature of reality. This brings us to one of the most curious concepts tied to the Big Bang. Repulsive gravity. We all know gravity is the force that pulls things together. It's what keeps your feet on the ground and the Earth orbiting the Sun, but under certain extreme conditions. Einstein's equations allow for a different kind of gravity, one that pushes things apart. We've never experienced it directly because the gravity created by objects like planets and stars is always the attractive kind. But the theory suggests that if you have energy spread uniformly throughout a region of space, it can generate repulsive gravity. Many cosmologists believe that in the very early universe, a uniform field of energy, sometimes called the inflaton field, filled all of space. This field would have generated a powerful repulsive gravity, pushing everything apart and causing space to rush outward. So, the bang of the Big Bang might not have been a traditional explosion at all, but rather a spark of this repulsive gravity, pushing everything apart from an infinitesimally small point. Our journey through the beginnings of the cosmos has taken us from cosmic inflation and quantum fluctuations to the mind-bending idea of repulsive gravity. While we don't have all the answers just yet, each question we ask and each theory we test brings us a little closer to understanding the incredible story of our cosmic origins. The universe is full of mysteries, but the quest to solve them is one of the most exciting adventures we can embark on. Thanks for joining me on this journey. If you enjoyed this exploration of the cosmos, don't forget to like, subscribe, and hit the bell for more deep dives into the universe's greatest secrets.